Good morning, everyone, and welcome to Magical Math Morning Sessions. Today, like every Monday to Friday morning, 7 a.m., what you're going to learn a new matrix based on the Vedic maths or shortcuts or mental maths. Today, we are going to continue learning the final part of the divisibility tests because we learned the divisibility of simple numbers like 2, 3, 4, 5, 8, 9, 10, and also 7, 11, and 13 we have learned. But how to extend this one to all numbers? That's what we are going to learn today, because when we are going to do the division of any numbers, we may have to divide with a little bigger numbers. Correct? And there we should be able to divide not only with the simple prime numbers but with the composite numbers also. That is what we are going to learn today. We will be learning the divisibility of some composite numbers today. And the trick can be extended to any composite number once you understand for two or three numbers. Okay, let's take this. We'll start with the simplest of the complex composite numbers other than 4, that is divisibility by 6. Divisibility by 6. And 6 is the number which can be written as a product of 2 and 3. Therefore, if the number has to be divisible by 3, it has to be divisible by 2 also, it has to be divisible by 3 also. Suppose you have one number like 252. What we should do? You check first, is it divisible by 2? That means it should be even. If it is an odd number, then it is not divisible by 6. So directly we can reject it. So first thing, it should be even means it is divisible by 2. Then we'll check with 3. With 3, what we do? We'll add the digits. That is called as a digital sum. Have you heard the term of a digital sum? Digital sum means what you are going to get by adding all the numbers and keep on repeating the same till we get a single digit number. For example, digital sum of 252 is 2 plus 5 plus 2, that is 9. 9, is it divisible by 3? Yes. Therefore, it is divisible by 6. And we'll say yes, it is divisible by 6. Let's learn the concept of digital sum. Suppose if you take 2, 5, 6, 4, double 2. What is the digital sum? It is nothing but 2 plus 5 plus 6 plus 4 plus 2 plus 2. This is 10, 17 plus 4, 21. But we will not stop at 21. Again, we will continue to add this. 2 plus 1 equal to 3. Finally, we should get the single digit number. This is called as the digital sum of this number. Okay, and for us to check the divisibility, this is okay. But the concept of digital sum is you keep on adding all the digits until and unless you will get the final single digit number. Now 2, 5, 6, 4, double 2. First check is it a even number? Yes. So first condition, it is fulfilled. So second condition, is it divisible by 3? Yes, 21 is divisible by 3. So this is divisible by 6. Yes. Correct? Now, let me give you one number. Please check and tell me, is it divisible by 6 or not? Let's take 3298. Check, is it divisible by 6 or not? Just type yes or no. Yes means yes, no means n. Just simple one letter is sufficient. Is it divisible by 6? No, because it is divisible. Yes, but the second condition is when you add all 9, you can eliminate 3, you can eliminate 2 plus 8 is 10. Correct? No, that shortcut what we have learned. 10 is not divisible by 3. Therefore, second condition is no. Therefore, finally we'll say no. No. Suppose if I give you the same thing 4518. Check this. Is it divisible by 6? Is it divisible by 6? Type it. Yes. I'm getting the answer says yes. Correct? No, it's an even number. When you add 8 plus 1, 9, 4 plus 5, 9. That means all the digits are divisible by 3. Therefore, both the conditions are fulfilled. So we'll say yes. We'll say yes. Correct? No? Now, let us extend the same thing to 12, because all other numbers we have already learned. Correct? No? So now we'll go for divisibility by 12. 12 can be written as 2 into 6 or 4 into 3. But when we take 2 into 6, 2 is a factor of 6, or 6 is a multiple of 2. That means if you check the divisibility of 6, obviously it will be divisible by 2 also. So we should not consider this. How we should express 12 as a product of two numbers? It should be co-prime numbers. Co-prime numbers means the numbers which do not have a common factor. 4 is a composite number, it's okay. But 4 is not having a common factor, or 4 is not divisible by 3. That's why we can say 4 and 3, if we check whether it is divisible by 12, if the number is divisible by both 4 and 3, then it will be divisible by 12. Let's take one simple number, 300. First, what we do? Is it divisible by 4? Yes, because last two digits are 0, means obviously it will be divisible by 4. No? And is it divisible by 3? Yes, sum of the digits is 3. Therefore, yes. Therefore, it will be divisible by 12. You can check it. 12 2s are 24 and 12 5s are 60. Yes, 25. It is yes. Correct? No? Let's take one number, 4248. Now, first you check with 4. Easy. Last two digits, 12 4s are 48. Yes. Then check with 3. 4 plus 2, 6. Removed. 4 plus 8, 12. Removed. Because the moment I get a sum of digits with 3, which is divisible by 3, I will stop there and I will count the remaining numbers. When you add everything, yes, it is divisible by 3 also. So this number is divisible by 12. Understood? I will give you one number. Same thing, if you want to extend the same thing to 15. How do you check that? 15 can be expressed as a product of two prime numbers or two co-prime numbers, 3 and 5. So what we do? You check, is it divisible by 3 and is it divisible by 5? For example, if I take 7 3 3 5, divisibility by 5 is easy. Correct? No, it should be having either 5 or 0 at the end. Now check only for 3. 3 3, I will review. 7 plus 5 12. Yes, it is divisible by 3. Therefore, this is divisible by 15. If I take the number 108890, is it divisible by 15? Means first with respect to 5, yes. Now we have to check with respect to 3. 9 gone, 8 plus 1, 9 gone, only 8 is left. Correct? No? So it is not divisible by 3. Therefore, with respect to 15, this is not divisible. Understood? Whatever the composite number, if it is given, you check whether it can be expressed as a product of two co-prime numbers. That means these two should not have any common factor. And you check the divisibility of those two, it will be sufficient. Now, let us extend the same thing to 18. Now, give me the two factors with which we should check. Type those two factors with which we should check the divisibility of 18. If you have understood the concept of co-prime numbers, type the two cofactors with which we should check the divisibility of 18. Type that. So 1 we got is 6 into 3. 18 can be expressed in many ways. 1 into 18 is useless because with 1 every number is divisible. Is 6 into 3 the right choice for 18? Everyone is giving 6 into 3. But what I said, these two should be co-prime numbers. Are these two co-prime numbers? No. Because 3 ones are 3, 3 twos are 6. 6 is divisible by 3. Correct? No, 6 is a multiple of 3. So we cannot use 6 into 3. 6 and 3, they are having a common factor of 3. Other than 1 and this number, they have a common factor of 3. We cannot use them. So we should use 2 into 9. Is 9 divisible by 2? No. Therefore, I will be checking whether the 8 number is divisible by 2 and 9. Then it will be divisible by 18. For example, let's take a number of 432. Tell me, is it divisible by 18 or not? You check the number by 2 and you check the number by 9. 2 means very easy. It's an even number. Correct, no? Check only with 9. The digital sum should be divisible by 9. Check it and tell me whether it's divisible by 18 or not. No? Okay. You add all the digits. 2 plus 3, 5. 5 plus 4 is 9. That means it is divisible by 9. Correct, no? Any one, if it is not divisible, then you should say no. It is divisible by 2. Yes. Is it divisible by 9? Yes. Both, if it is fulfilling, means we can say yes, it is divisible by 18. 9, it is divisible, no? 4 plus 3, 7 plus 2, 9. So 432 is divisible by 9. That's why it is divisible by both the numbers. That means for a number to be divisible by a composite number, you express the composite number as a product of two co-prime numbers. Those two should not have any common factor. And if it is not divisible by even any one of these factors, we'll say no. But to be divisible by this number, it should be divisible by both of its co-prime factors. Now check with this 8226. Is it divisible by 18 or not? Tell me. First we'll check with 2. Yes. Now check with 9 and tell me. If it is divisible by 9 also, then we can say it as yes. Yes, sum of the digits is 18, which is divisible by 9. So yes, both are yes means yes, it is divisible by 18. Now you understood? Any number you should be able to express in terms of a co-prime numbers. Correct? Now, if we get any number like 24, what we should do? What are the prime factors it can be expressed? 2 into 12, we cannot use it. 3 into 8, yes, we can use it. But can we use 4 into 6? No. These two are having a common factor of 2. These two are also having a common factor of 2. Correct, no? So what we can use? You should check the divisibility by 3 and 8. Understood? Any number, you try to express that number as a product of co-prime numbers, and then we can check whether 4,28,556 is it divisible by 24. Instead of checking by 24, first you check by 3. Sum of the digits, correct, no? 4 plus 8, 12. 6 also I will eliminate. 5 plus 5 plus 2, 12. Yes, this is divisible by 3. Now check with 8. 8 means what we do? You check only the last 3 digits. 8 6 are 48. Correct, no? 8 6 are 48. 7 is left. 7 and 6. 76 is not divisible by 8. Therefore, this is not divisible by 24. Correct, no? It's not divisible because it's not divisible by 8. Cross check this one. Only last 3 digits we'll check. 8 6 are 48. 7 is left. And 76 means 8 9s are 78. It's not divisible by 8. Therefore, it's not divisible by 24. But now tell me, is it divisible by 12? Confirm. What you will do? For divisibility of 12, you check with 3 into 4. Already we checked with 3. Directly check, is it divisible by 4? And type it whether the number is divisible by 12. Type yes or n. Yes for yes, n for no. It's not divisible by 12. Someone is typing no. This number is divisible by 3. Already we checked. Only check with 4. Last 2 digits. 56. 14 4s are 56. How can it come no? It is divisible by 4 also, 3 also. Correct? No? That's why it is divisible by 12. Okay? We should be doing very fast. Now, why I cancelled some numbers? Yesterday, I explained you the divisibility test for 3 and 9. Correct? That I recommend you to go through that one. In the yesterday's video, I have told how to check the divisibility for 3 and 9. There is a shortcut for not adding all the numbers. This is a shortcut upon shortcut. So that it will say, please go through that one, you will understand this. Okay. Now I want to give you some numbers. Divisibility by 15. Please check 1,42,725 and tell me, is it divisible by 15 or not? 1,42,725. We'll be checking with 15 can be written as 3 into 5. With 3, with 5 definitely yes, because the last number is 5. With 3 you check, yes, it is divisible by 3 also, therefore it is yes. Correct, no? Now check whether this number 1,71,666 is it divisible by 18? Please check. How fast I will do, I will tell you. 18. Directly I will go for 2. Even number. Yes. Then I will like to go for 9. 1 plus 7 plus 1, 9. We cancel. And 6 3 is 18. That is also divisible by 9. So directly yes, we'll say. You understood how fast we do? Where these are useful? Whenever you are doing some division of big numbers, like you want to divide 2,56,422 divided by 4,248. What you people do? You will be dividing by 2 and then by 3 and all you will check. But instead of that, what I'll do? I will check this number and this number. Are they divisible by 6 or 12 or 24? Then directly I will cancel with those numbers. 12 is a easier number. The below number is divisible by 3 also and 4 also. This is divisible by 12. So what I'll do, I will check with the above number divisible by 2 and sorry 3. 4 it is divisible? No. So what I'll do, I will divide these two by 6. With 6 if I cancel, then it will come a smaller number, then directly I can go for the next numbers. Okay, there we are going to get them, because before going to division, you should know with which number we should divide for cancellation, and then you will be able to do them fast. Tomorrow we are going to learn about the division tables, how we can master to check whether first we should go ahead with the division of this number or not. And for that, going through the three topics what we have learned day for yesterday and today is essential. The people who are absent were absent yesterday and day for yesterday, please go through the recording in the YouTube channel of Ram's Maths Hub. The live session is there, and then you will be able to become expert in checking the divisibility tests. Correct? And with this, we are going to end this session. Become thorough with the divisibility tests, and then you'll become a master in division of any numbers. See you all tomorrow morning, sharp at 7 a.m. again at this space. And those people who have not yet subscribed to the channel, please subscribe and share with all the people, your friends. And then you keep practicing with your math buddy to become expert in maths. Then only you will be able to say like me that maths mein maja hai. Bye bye. Take care.